This is the second mini lecture for section 3.2 of the textbook. Now we're going to illustrate 147 plus 69 using place value cards marked for 100s, 10s, and 1s. So I'm going to begin by just writing down the 100s, 10s, and 1s here. You should imagine that, if you were doing this in a classroom, maybe you would have cards made out of tag board and laminated or something. Each card is divided into three parts: the hundreds place, the tens place, and the ones place. And you would use some kind of manipulative, a checker or a token or something, to represent each of the numerals. So for example, 147, we have 1, 100, 4 tens, 7 ones. So notice how we're using place value at this point. When we were using mat strips and units, we were not really using place value because a mat represents 100 no matter where you put it. So we are not using location. Here we are. This little checker is going to change its meaning depending on where I put it. It's in the hundreds part of the card, so it represents 100. But if I put it over here, it represents 10. And if I put it over here, it represents 1. So now I'm making use of place value. Okay, so let's represent 69 on this card. 6 tens, 9 ones, okay, in step 1, we just combine them into a single card. So just imagine sliding one of the cards off onto the other, section by section. So you have the 100, and then you have the 4 tens, plus the 6 tens. Then we have the 7 ones, plus the 9 ones. Now, we're not allowed to have more than 9 in any slot. So my next step is going to be to exchange 10 of these 1s for 1 10. Okay, so now I have my 100 and my 10 tens. Plus an extra 10. And I have my 6 ones that are left over. And then finally, I exchange 10 tens for 100. So that gives me 2 hundreds, 1 10, and 6 ones. Okay, but again, what's really important here is to show how you go through the intermediate steps. You can't just draw the 2 cards and then draw the answer. Okay, the goal here is to understand the process. In our next representation, instead of drawing, for instance, like 4 objects to represent 4, we're just going to use the digit 4. But the work is going to be pretty much exactly the same. Okay, exact same steps. We're just using digits now instead of a number of objects. So I'm going to make something kind of like a ledger that you might use in accounting. And we have 3 columns, hundreds, tens, and ones. And we're adding 100, 4 tens, and 7 ones to 6 tens and 9 ones. And I just add column by column. 7 plus 9 is 16, so I have 16 ones in all. 4 plus 6 is 10, so I have 10 tens. And 1 plus 0 is 1, so I have 100. But again, I'm not allowed to have more than 9 in any column, so I'm going to make exchanges. I have 16 ones, so I'm going to keep 6 of those ones in the ones column, but 10 of them I'm going to exchange for 1 10. So now instead of having 10 tens and 16 ones, I have 11 tens and 6 ones. Represents the same amount. I just have them distributed differently, and that way I have less than 10 in the ones column. Okay, then I still have my 100. Now I have the same problem with the tens column, so I'm going to exchange 10 of those tens for 100. So 110 stays in the ones column. The other 10 get exchanged for 100. So I end up with 2 hundreds, 1, 10, and 6 ones. But you see that the steps are exactly the same as it was with the math strips and units and the place value cards. You combine, and then you exchange from the ones, and then you exchange from the tens. Now let's illustrate 147 plus 69 using the instructional algorithm. Okay, it begins much like you would begin writing the final algorithm that you learned in grade school. But I'm going to add each place separately and write them all down below in 3 rows. 7 plus 9 is 16, so I just write the 16 there. Okay, that's 7 plus 9. 40 plus 60 is 100, so I write the 100 down below. 100 plus 0 is 100. And now it's easy to add those 3 up. So at this point, why don't we recall what we would write in grade school? The final algorithm. We have 147 plus 69. And here's what I would do. I would add 7 plus 9 and I get 16. But I put the 6 down here and the 1 up here. Now, what's really going on here? That's what I need to be able to explain to a student. What's going on is that when I add 7 plus 9, I get 16 ones. So I'm going to keep 6 of the ones there, but 10 of the ones I exchange for 1 10. So this little 1 here, what is that? That is the 1 10 that was exchanged from 10 ones. So if a student were to ask you, what does that 1 mean? That's what you would say. And then let's see, we have 1 10, 4 tens, and 6 tens. That gives us 11 tens. So I'm going to keep 1 10 there, but 10 of those tens I'm going to exchange for 100. And then 100 plus 100 is 200s. Okay, but remember, if you're asked to explain what the different parts here mean, you need to talk about ones, tens, and hundreds. Don't just talk about how, well, you get a 16, so you put a 6 down here and you have to put the 1 up on top. That's not really explaining what's happening. It's explaining what you write down, but we need to say a little bit more than that.